Going to put our recording and we will start. So today we will move to the new unit about data modeling. So we will take a look to modeling libraries, okay, but just very brief because so first, let's take a look. The first model is called, it's most used for statistics. Okay, it's called statistics models. And like I said, this is mostly used for statistics analysis. So if you are more interested in like statistics learning, then maybe you can take a look in more detail. Okay, so there are also quite a lot of models, and we will just get some very basic idea. And the second one is sklearn, okay, scikit-learn. So this is for statistics analysis. Okay, and this the scikit-learn is for machine learning. Okay, and the machine learning itself is a huge topic. There are a lot of material. So so we are not going to discuss in more detail. So over here, we also just going to get some basic idea. Okay, give you some information, and for studies analysis, I believe math department they have some more advanced math course regarding statistics learning, and for machine learning, and we have another dedicated course to discuss about Python. So Python oriented, okay, machine learning. So it's a complete package and including deep learning and reinforcement learning. And generally speaking, machine learning, you have supervised learning, unsupervised learning, and reinforcement learning. Okay, and nowadays a lot discussing about deep learning. So deep learning, we have like convolution neural network, RNN recurrent neural network, etc. So that's Python based, have a lot of matured package available. Okay, and so that we have a course CS 453, okay, 400. And for statistics, if you want, I don't but there are some math course. It's 57 something, okay, kind of. Maybe I'm not too sure, okay. And they are R-based. Okay, it's a different one, not Python based. Okay, and generally for CS we use Python based. Because for Python based, the advantage is very powerful for text processing. And for math, they are more like leaning toward math model, etc. So interpretation from math. But for CS, there are also a lot of like images or audio, video, and text, etc. So how do we, and especially with the text, and the Python is very powerful regarding this. Okay. Okay, so that's just two general model related with Python. Okay, we will take a look, okay, glimpse. Okay, let's see. And the beginning, what we will learn is we're still going to based on pandas. Is it a data frame? Okay. And model. Is it so interfacing between pandas and model? Is it? And generally speaking, is that the common workflow, is it for model development? Is it? And we already learned using Panda for loading data and the data cleaning. Is it? We already learned that. And we also learned what, like data aggregation. Is it data wrangling? Is it? So pandas for data transformation, we also learned. Is it? And it says all feature engineering. Is it? But we will also see that for statistical model, like regression, that can be used to find the feature importance, that, and also machine learning, they also have some to identify feature, that, so feature engineering. Okay, but over here, what we said is before we build the model, is that you may also need to do some data aggregation, is that okay, and also sometimes you want to pick a certain feature, is it? So after we do that, so that's basically what this CS433 focus on, is that it's regarding data analytics, that it's more, it's doing the pre-work for you to build the model, that because you also have a project that do web scripting, that a lot of time you may also need scraping data from web, that, and then in that case, the data, the raw data may be messy, then we need to do, how do we load the data with different file formatting, etc. And then how do you clean data? How do you wrangling data and aggregating data? So that's all of the pre-work for you to build the model. Okay, then to start. Generally, when you after you build the model, you can use model to do prediction. Is it based on existing data? Is it, and then for future unseen data, when the data comes, how you predict? Is it, that's how the model plays. Okay, so that's the general idea. And then next, let's see. Over here, if you recall, is that if you recall, for model building, no matter static or machine learning, is that they need to use numbers based on number. Okay, and also it's at the point of contact, is it between pandas and other analysis, like it's NumPy array, is it? So it's numerical data, is it? And how do we get off the data, is it? Later on we will also see. And anyway, here says, how do you turn a data frame? So data frame is from pandas to NumPy array. You can use the data frame dot values property to get the NumPy array, is it? And we can also use the dot log to do the indexing, is it? But a lot of time, the data we get is categorical data, if you recall, is it? For the categorical data, we have a method called get dummies, is it? Like the color, is it? Original, you have color column, is it? But under column, you have red, blue, green, is that RGB, and some other color, is it? And but those cannot be directly applied to either machine learning or statistical learning. You cannot. Is that you need to convert them to numeric data. And how do we convert to numeric data? If you recall, the get dummy. The get dummy then will convert like, okay, color red, color green, color blue, something. That is, use 1 or 0, is it? Something like that. Is it? It's all convert to numbers, and then you can use those as your feature. Generally, we call all of those columns as features. Okay. Okay, so those are interfacing. Let's see. Okay, and in Python there is another package library. It's called Patasi. Okay, and we will see, especially for statistical model, it involves math. So maybe it's a comprehensive, complicated math model, and how do you provide the formula? The formula. So it says Patasi provides a way for us to do small string-based formula syntax. Okay, syntax. Then we can fit the model. Okay. So generally speaking, is we use training data to fit model. To fit model. So basically, this is to train model. To train model, and train model, the purpose is to find optimal parameters for your model, for the model, like a linear model is AX plus B, So A and B are considered the parameters, okay? But you need to find the optimal one. Optimum one, that means, okay, if you use this linear model to approaching your data, so here is you have scattered data, and here is your linear model, and this linear model, then definitely, if you choose another one, just think about this. If you choose this one, or you choose like this one, then definitely those two, not a good option. And this one fit the best. And how do you find this fit one best is you need to find those two parameters, for the formula, math formula, depends on what kind of model, this is a linear model, you can also have polynomial model, you can also have logarithm model, logistic models, all sorts of models, So that's why, based on those scattered data, how do you find the best fit one, So that's the training purpose, okay. Okay, so anyway, this Patasi is some package that can help with some small string-based formula. Okay, we will see that, okay. That's much more straightforward, okay. And for this, we will take a look in our code, okay. And also for those categories, we will take a look. And for statistical model, it says some kinds of models can be found in this library, okay, linear model and the general linear model and the robust linear model. So even within linear, there are different kind of linear model, okay. And you can also do variance analysis, okay, time series and some other, okay. And we will just discuss about linear model, okay. So as the starting point. Regarding linear regression, so that's what we will see with our statistics learning's introduction, okay. So that's a statistics model, And from math, I believe you all learn linear regression, So this is some variable, So this we call it independent variables, And the Y generally we call that dependent variables, And the regression can be used to extract important independent variables. Is it because it may not? So suppose you want to consider the model, is it, or how about like crop production? Is it for crop production? So there are a lot of weather condition. Is it a soil, fertilizer, water, all sorts of factors, is it? And so all sorts of, so like this general x1, x2, x3, x4, something, is it? So those are all independent variables. Independent, so in statistics means they don't correlate with each other, as they are independent impact the crop production. So crop production is y, is it? Then you want to know which of them plays very important role about crop production, is it? So how do we do that? Then we can use regression, then it can tell you, okay? So linear regression is then just like what we previously say, all of those are sample data. Sample data, is it? So this is independent variables, is it? Y is dependent variables, is it? Y is independent variables. And so those are samples, and based on sample, you wanted to derive this equation, is it? This equation, so this is linear, a linear equation. Is it? You want to arrive this. So then the idea, how do you find the coefficient alpha and the beta? Is it? So here the idea is if you're going to, in the statistics model, they use, we call it ordinary least square. There are all sorts of least square, is it? And here it's ordinary least square. What is ordinary least square? Is, so this is your sample, is it? This is your predicted. And predict, you don't know, you just assume, okay, I have this equation exist with alpha plus beta x, is it? So this is sample. With the sample, then you have the sample x value, is it? And then you can find the y hat, is it? So y hat is calculated based on the sample value, is it? You calculate it. And you have the real y. So this is yi, is it? And you also have the, okay, so this 6 is the real yi, is it? And then you can find the discrepancy between these two. So that's yi minus yi hat, is it? Yi hat. And this is least square, is it? And you want to square it, and you sum all of the I, is it? So I, so all of the I, is it? Over here we have 4 samples, 4 samples. So I from 1 to 4, is it? You want to sum them, is it? And how do you make this is a perfect versus this one or versus this one? Then definitely you can see the discrepancy between the sample and this predictor or the other predictor is much larger than the discrepancy of this perfect fit one, is it? So in math, then you can try to minimize this, is it? And if you do minimization of this, and it involves some calculus, is it? And you can find the parameter, the coefficient alpha as this, and y or beta as this value. Is it? That's how we find, we call it ordinary least square, okay, to estimate alpha and beta. Okay, and once you have alpha and beta, then you have this estimated y calculation, is it? So this is, we call it linear regression, okay? Okay, so we understand the linear regression, and we will later on. And you can also have multiple. It's not just with a single independent variable. So you can have more than one independent variable. Is like what we say, maybe weather, maybe soil, maybe fertilizer, and something else. Is it? So you can plug in all of the independent variables. Is it? And but this is still linear relationship. Is it? You can also have polynomial relationship and some other relationship. Okay, so that's regarding linear regression, etc. And we were saying machine learning, you can also do linear regression, okay? But the focus is different, okay? And let's see, yeah, so here, comparison between, you choose statistical model or sklearn, okay? And it says statistical model is useful when it comes to generating all regression output, okay? And it says under one output frame. Okay, so for studies for regression, then you can find some related relevant independent variable. Okay, so that's quite useful. For studies for machine learning, sklearn, etc. For sklearn, and the idea is also try to find the best fit parameter, parameter, but it's more towards the prediction accuracy. Okay, so that's you care about the future prediction using the model you predict. Okay. And there is another kind of, we call it logistic regression, okay? And in machine learning, be careful, even though it is called regression, but this is for classification. Okay, classification. So it's regarding the probability. So not like a linear regression, okay? So the probability as some binary. So it's for some binary variable, the dependent variable, okay? So y, the dependent variable is some binary value. So either true or false, okay? So 0 or 1. And 0, 1, it's not either black or white, 0 or 1. So it's the probability going to go get 1 or get 0, okay? Then you will classify that it is true or false, is it? So logistic regression, and the idea is it uses sigmoid. So use sigmoid function. Okay, so sigmoid function, the curves looks like something like this. So it's between 0 and 1 as for y, okay, for the dependent variable. But generally, dependent variable and independent is for statistics, okay. In machine learning, we call this target. Okay, in machine learning, it's a target value, okay. So it's binary with that. It's either 0 or 1, is it? And so it's basically what you said is, okay, so the probability is between, if the probability, so over here that's okay, greater than 0.5, then you said, okay, it's true. Okay, so over here is the probability. Okay, 50%. If it's less than 50%, no matter what the dependent variable value is, then it is false. Okay, otherwise, no matter what the value is, it's going to be 1. Okay, so that's the idea, okay, regarding logistic regression. Okay, so then next, let's take a look. How do we do it in Python? Okay, so the first part we discuss is about interfacing between pandas and model code. So we quite familiar, is it, with data frame, is it? And here you create a data frame with what? With dictionary, is it? And you can get a column, you can get, and here we say data value. As a data value, then you get this is NumPy array. Is a NumPy array. Okay, so it's all numbers, is it? And you can also give your column name, is it, for data frame. And so we quite familiar with this. So nothing new, is it? And then next, let's see, okay. So over here, you can also specify, so this x0 and x1 is from the previously that we defined the data frame, is it? And you can specify, is it, with the dictionary's key part, is it? And you can use the .log and also to get the corresponding the columns, basically, is it, all of the value. And the data value also give you a NumPy array, okay. And then next, let's see, how do we handle categorical data, is it? And then here, you add a new column, is it? So here we add a new column, is it, on the original data frame, is it? And the new column is going to be categorical data, is it? And the category is A and B, is it? And then we can have this data, then we assign it to a new data frame, okay? And so now the original one has what? Has 1, 2, 3, and plus that categorical data, is it? Categorical data like A, B, is it, like those values, okay? So the original data has 4 columns, is it? And then let's see, because for like previously what we explained, is it, no matter it's that statistical models or that sklearn, is it, it all used based on numbers, is it? So for the categorical data, we needed to convert it to number, is it? We can use the get dummy, is it? And get dummy, and if you wanted to add the prefix for the, so this A and B are the values of categorical data. Is it, now you want to use them as a column, is it? And the value then is going to be either 1 or 0, is it? And if you want to add a prefix, is it, then you can set the prefix, okay, prefix. And then we add this new columns, is it, to the previous data, but you're going to drop the original categorical column, so that you don't need that one after you convert the categorical data to dummy 1 or 0. We don't need that. Okay, so this is how we handle dummy data. Okay, and what next one try to show us about that PATC. Okay, how are we going to use it? And it's that it's string-based formula system. Okay, and it's inspired by R. Okay, and as in statistical models. Okay, and for like a linear regression, is it basically then in PATC, it can be described. So this is dependent variable, is it, and the independent variable. Okay, so then if you want to use PATC, then you can just provide this as a string, is it? Then it knows that it's going to be a linear regression model, okay? So over here, this is the data frame, is it? So we see the data as a data frame. And you have two independent variable and one dependent variable y, is it? And then you said, okay, you import this patency, is it? And you are going to use, so this is the column, is it? Column name. So you're going to use a column name, is it? For your matrix, is it? For your matrix. And what you can do, and then specify the data source, is it? And then you can get to the matrix, is it? And we can see. So it's pretty straightforward, is it? Then it says, oh, your design matrix for the Y to give you like this. And for the X, is it? Then to give you those two independent variable, is it? And this for the interception part, okay. Okay, and after that, you can convert it to NumPy array, is it? So you can get NumPy array. You just call that as array, then you plug in that patency matrix. So now you kind of build the interface, is it, from the original data frame to NumPy array values, okay. So that's regarding regarding patency, okay. So next, let's see, how do we use the studies model, okay. If you want to use that studies model, then you need to import it, okay. So we can import the API, and we can also import its formula, is it? And over here, that's for linear regression. So then let's see, how do we use it? You can see it's then quite straightforward, is it? So this is linear. And for different one, you need to refer the studies model package to find the corresponding model, okay? And here we use linear regression with ordinary least square. Ordinary least square. Is it to find the linear regression, okay? And how do we do it? Then you can see it's quite straightforward, is it? So you first, so this is you create model, is it? And here you specify the formula, is it? So the formula is going to be linear regression, okay? Using the column from the data. Is it from the data frame? So you specify here is the data source. Data source, is it? And then what is this here? Is it? What is this? So this is for the categorical data. Is it for the categorical data? Okay, so it's also going to take care of the category. So let's take a look at the data cat, okay. Data cat, where is it? So this is our data cat, is it? The data cat, if you recall, so we have ABAAB, is it? So that's this original, so this is a category column. Then we have AA or ABAAB, is it? So this is our data cat, is it? And we also have this categorical column, is it? But this column is still string, is it? Not number, not number yet, is it? But you can see for categorical data, if you specify, and all this part using the get Damiet explained, you yourself clean the data, is it? Wrangling data, is it? And here, what in this model shows for categorical data, you can also within the formula expression, you can specify, okay, I'm going to take care of the categorical data. Categorical data. Okay, then it will do the kind of like the dummy. So basically, you let the model do the dummy part for you. Okay, for you. Okay. And then in this case, if we take a look at the result, you will see that the categorical data, the result, it will only take care of the the B part. We have A, and we also have B. Is it? It will take A. It suppress the A. Is it suppress? Because over here it also consider interception. If you suppress interception, then it will consider both A and B. Okay, later on we will see. But because A and B are related, once you have B information, then you can also derive A. And so it's not mandatory, you got to have. But anyway, so here, basically you're going to have three independent variables. There's three independent variables. Okay, so how do we use that linear regression? Then you just plug in, you create the model, you specify the model's formula, is it? Because you need to specify the independent variable, is it? And the data source. So this step is you create a model. After you create a model, you just call what? You just call the model's fit. Okay, so this is to try to using all of the scattered data, the sample, is it, to find the best fit line. Okay, so that's what this part does. Okay, and it will use all of the samples. Is it? So basically this data is samples. Samples, is it? And you're going to fit. And the fit, you're going to have the model. Okay, so it's alpha plus beta x something, is it? And over here you have 3 1, is it? So beta 1 x 0, or beta 0 x 0, beta 1 x 1, and the beta 2 x2, so you have 3. So you're going to find all these 3, and this is called interception. Intercept. As that, so you need to find all of those coefficient as a coefficient. Okay, you find the best line. Is it to find the best line? Find the best line basically is what? Is the, so this is alpha, and this is beta 0, beta 1, and beta 2. Okay, so find all of the coefficient. Is it coefficient? And how do you find? Then you just call the results, the parameter, is it? And for studies model, the nice thing, it also give you some studies summary, okay? And then you can see a lot of ideas, okay? So over here is this, say, okay, it tells you dependent variable, is it? And the model, so that's the summary, regression summary, is it? And the method is ordinary list square, is it? And it also tell you number of samples, is it? And the degree of freedom, is it? Degree of freedom. So in math, you learned, is it? Those are degree of freedom. Basically, it's the independent variables, and we have 3, is it? Independent variables. That's why degree of freedom of model is 3, is it? And this R square, R adjusted R square, this, if the value is close, supposed to be 0 between 1, okay? So R square value, okay, 0 between 1. So if it's close to 1, then that means your model is a good model. And in this case, we can say it's not. It's even less than 0.5. Is it? So this model itself is not a good model. Okay. So that's regarding part of the summary result report, quite helpful, is it? And it gives you more information, is it? Intercept and each independent variables coefficient, is it coefficient? And the standard error, is it? And the t-value and the p-value. And instead of p-value is also very useful. Is it very useful? And if the p-value, so R should be close to 1, then it's good. Okay, and the p-value, if it's small, the smaller the better. The smaller the better. It's like 0.005. That's good. But over here you can see the result is far greater than this. So that means all those coefficients are not good one. So some reasons, maybe your samples too small. Is it? Samples too small. Is it? And generally speaking, regarding statistic, should greater than 30 samples. Is it? So the more the better, is it? But of course, not always, because sometimes it can cause overfitting, is it? So anyway, so that's the general idea, okay, about the statistic model, okay. We can see it's quite helpful, is it? So if you are very interested in statistic, is it, learning and all of those information, the report, summary report will be very helpful, okay, very helpful. Okay, then next, let's see the PATC, okay. And over here, yeah, we already, this part. Oh, then the next one is try to see the negative sign, is it, in the formula. What does that mean? And that means you can remove the intercept. If you remove the intercept, did you see the coefficient part? Then the A will be included. Okay, so it depends on if you want, okay, to include the intercept, okay. And you can also suppress intercept by, for PATC matrix, okay, you can plus it as +0, then it can also be suppressed, okay. Then in this case, if you see the term, is it is no intercept, it's just x0 and x1, is it? And if you have the x and x, the dependent and independent variable, is it? Then you can also, NumPy, they also have least square model, okay, for the NumPy least square model, it can also find the coefficient and the residual, is it, coefficient and residual. And then with the, how do we find more related information is you can also call. So once you have this coefficient, is it coefficient, and the index here says, because this is with data frames series, is it? You wanted to know all of the coefficient, is the intercept and the dependent variable, is it? Then you can say, okay, you specify the independent variable matrix. You say design info, then column name. Okay, then it will report the corresponding coefficient. So here just shows us multiple ways you can do it, okay. If you want to also go with NumPy linear, okay, you can also do that. Okay, and then here we have more. And for PATC, that previously It's a linear model, is it? And you can also for x1, that variable, independent variable, is it? And what over here is that, okay, I first want to do absolute x1, is it? And then I plus 1. And then I take log, is it? And so what this model is x0, then maybe beta 0 plus beta 1, is it? And then you want to have your y model be predicted like this, is it? Then in this case, so this part for the x1 independent variable, you are not directly based on x1. You're going to do some transformation. Then with Patterson, you can just directly, did you see, describe it. Is it describe it? So that's why we see that's very handy. Is that very handy? Okay, and you can also do something more. Is it like using standardized and the center? Is it what is standardization? Is you take some mean, take some variance. Is it? And here is that okay. For x0, I'm going to do some standardization, is it? And for x1, I'm going to take the center, is it? And for linear regression, is it? Linear model, okay? So Patterson can describe then like this, okay? Then did you see? Then to find the intercept. Then for independent variable, it's not x0 and x1. It's going to use based on the transformed result, is it? Because a lot of time you also want to do that, okay? And what the next one try to show is after you do the transformation, is it? So design info, design info. The design info here, is it? For the design info, you can also, what you can do is, then you may apply some new data. So for the original data, you may apply some transformation. Is it transformation? Then for new data, you want to keep. So this is for predicted or evaluated data. Is it? You also want to do transformation. Then in this case, you can call Patterson, you can call build design matrix. Is it? And use plug in. This is not original. This is new data. Is it? But with what? With original. So keep original. Did you see? Keep original transformation. You're going to apply new data also with original transformation. The way to do it, you just call this build design matrix and plug in with whatever the original transformation formula is, okay? Okay, and sometimes maybe you want to have both matrix, is it to be together considered as some single column? Is it? How do we do that? Then in that case, then you want to find like a beta 0. Is it? Then in this case, then you needed to add that I. Okay, that I. Okay. Then did you see this itself will be considered as a single column? Okay, when you do the like statistic learning. Okay, then you can do something using the Patterson to specify something like this. Okay, so here is just to try to show different ways. Okay, and also over here it says for Patterson, you can also do the kind of dummy data, is it over here, key one is categorical data, is a category. And when you apply the patency, is it, then did you see it automatically converted to dummy data, okay. So it will also take care of this. And like over here shows, if you do that +0, it will suppress intercept. And after it suppress intercept, then both A and B, the dummy value, it will give you the matrix, and after you get this, then you can do the model, you can do the model. Okay, and over here it also shows you can also call the C function, C function, and then it can also the K2, K2, let's see. K2 is numerical data. If you take a look, K2 is number, and when you call that C, when we do this C, okay, then what it does, it get it to like the categorical. Okay, so that's it said it can be interpreted as categorical data. Okay, so that's what so it kind of it allow you to get it back and forth. Okay, so it shows more. Okay, and sometimes maybe you also needed to consider the correlation. So this is. So suppose this is x1, this is x2, You may also want to consider x1 and x2 multiply together, And as that, using that as a column, then in that case, what you can do is x1 colon x2. And basically it's x1 times x2, okay, times x2. So that's the correlated together. Okay. Okay. So I think we